Okay, so let's go through the reference models. So let's start from reference model because this other part it's already covered it.
Okay.
So under the reference model, what are the benefits of using layered? So with complex concepts such as how network operates can be difficult to explain and understand, but for this reason, layered model is used. So, if in case, let's say, you're asked to explain how the network operates, very difficult to operate. But in case you have the layered, you can mute your mic. So, in case you have anyway, with the reference models, then automatically you will be able to explain because you'll have to explain what always happens at every layer of the reference model. So we have a reference model specifically, it's a OSI, and then we have TCP, which is a protocol switch. So these are the available applications. So with OSI model, we have application, presentation, session, transport, network, data link, and then physical. Then when it comes to TCP stroke IP model, which is always okay, the protocol suite still we have there are four layers: application, transport, then internet, and then network access. So these are some applications available on the different layers. So we have HTTP, not only this, because there are so many, as we saw in the first part. At the transport layer, we have TCP and UDP, mostly two protocols. Then when it comes to network layer, you can see it's IP as a protocol. Then ICMP, even we have what we call the routing protocol, SPF, RIP, IGRP, they are all they fall at the internet layer or network layer. Then when it comes to OSI, data link, there are separate layer, data link layer and then physical. But under TCP, we have network access, which combines the two. And the main protocols at the network access layer or data link layer. Anyway, at the physical layer, we have Ethernet, then Wi-Fi, wireless LAN. Ethernet, it's wired, then wireless, it's W LAN. So the models, they're here. There are two: open system interconnection model, open system interconnection, OSI, reference model, and then TCP, which is transmission control protocol stroke internet protocol. So these are the benefits of using layered models. One, it assists in protocol design because protocols that operate at specific layer, they do have defined information that they act upon and a defined interface to the layers, either the above or below. It fosters competition. Because when it comes to the products, we have different products. At the layer 1, there are different products. Layer 2, different types of switches and other gadgets. So it fosters competition in the products from different vendors, and still on top of that, to make sure that each product it is interoperable. Interoperable with other products from different vendor, prevents technology and capability changes in one layer from affecting other layers. So if a cable fails to work in one of the computer, then it does not mean that it can't work on a different computer. So there is no any device that for it has a special internet cable, something like that. So it prevents technology or capability change in one layer from affecting other layers above or even below. So provide common language to describe network functions. provides common language that at every layer we know exactly the tasks that takes place or that happens. That. So these are different layers of OSI model, starting from layer 7, application, presentation, session, transport, network layer, and then we have data link layer, physical, and then the description. With application contains protocols used to process communication. The application that are already the protocols or the rules that are used to communicate between the applications. Presentation provides common representation of the data transferred between application layer. It's the format of the communication. Is it a PDF? Is it an image? JPEG? Is it compressed? Different format of the application. So we have session provides services to the presentation, services to the presentation layer, and to manage data exchange. So this keeps the sessions, because for different applications they have different sessions. So when it comes to session layer, it manages those sessions for different application or presentation. Transport defines services to segment, transfer, and then reassemble. There's so many things. It defines services to segment, how to transfer the segment, reassemble, even assemble the data for individual communication. So when it comes to network, provide services to exchange the individual piece of data over the network. So with network, it deals with IP addresses, both version 6 and then 4. Both version 4 and then 6. So data link layer describes method for exchanging data frames over a common media. For example, if the communication is on the same network, so data link layer, it describes the method for exchanging the data frames over a common media. Then lastly, we have physical layer that describes means to activate, maintain, and deactivate physical connection, dealing with the technology, how different technology how they do operate, or how they do work. So at the physical layer, we expect the tangible components like cables, then connector, different types of connector, different type of cables, the interfaces, all those. So under TCP, which is Transmission Control Protocol stroke Internet Protocol reference model, we have 4 layers: application, transport, internet, and then network access layer. So application, it's the same as the other previous application. Transport, the same as the transport, the other side, and then internet, the same as the network, and then network access that controls the hardware. So when it comes to hardware, these are the components that are tangible, the network components, devices and media. So in devices, maybe a switch, access point, media, still wireless, LAN, and then wireless. Okay, the wireless network interface card, then even wired, that makes up the network. So they're the same, because this one here, under this, it actually takes we have application, then we have presentation, then we have session. So these are 3 here. Then we have transport, it remains the same, transport. Then when it comes to internet, it's network. Then network, we have 3: data link, and then physical layer. Okay. So here, that is why we have the comparisons. The comparisons, as you can see, that the three are combined or compressed to make application. Then the transport remains the same. Network, it is internet. Then data link layer and physical combined to form network access layer. So the OSI model divides the network access layer, and then the application layer of the TCP into multiple layer. So under network access, that is why we have physical and then data link. Data link. Then when it comes to application, that is why we have application, then we have our presentation, and then session. So the TCP protocol suite does not specify which protocols to use when transmitting over physical media. Then OSI layer 1 and layer 2 discuss the necessary procedure to access media, and then the physical means to send data over the network. Cause those layers for them down separated, so you can discuss what the expectations on each layer. One, the tasks that are played on layer 1 and then layer 2. Layer 1 physical, layer 2 data link. So here we have the package. There is a packet tracer activity to investigate TCP and OSI model in the action. So in your account, you'll be able to see this lab. Part 1, you will examine HTTP web traffic, then display elements of TCP/IP protocol. So there are even guidelines on how to deal with the two parts. Now we can close and then go to data encapsulation. So within data encapsulation, we expect segmenting messages. So once the messages are segmented, then they're easy. It becomes easy and simple for the system to do the data encapsulation. So segmenting is the process of breaking up messages into smaller units. And then we have another term called multiplexing, which is the process of taking multiple streams of segmented data and interleaving them together. So when you look at what you have here, yes, this is the message from multiple sources, from this and then this, but they are not segmented. So it will not be easy for the network to interleave them on the network, meaning that it has to be one at a time. As you can see, maybe this sent from this and then this sent from, so it has to work on message per message. And for the case of management, easy movement on the network, maybe it won't be easy. So we need the segments. So why do we need to segment? We have two primary benefits: increase the speed. That if you have small segments, small units, it becomes the speed is already fast. So large amount of data can be sent over the network without tying up communication link. Without tying up the communication link. Then we have it increases efficiency on the segments which fails, which have failed to reach the destination are the ones to be retransmitted, not the entire stream. So here we have our sequencing method, but of course it is a sequencing method. It will help in multiplexing, that the segments are going to be sequenced with numbers and blah blah. As you can see, these are sequence numbers, but it helps all the segments from different sources to be interleaved on the network, not to monopolize the media, that it has to be so this computer sending when once it's done, and then the other computer to send. All of them, they will have to send, unless if the traffic is in need of the first priority, like voice or video, all these other applications, they'll have to pause, or traffic to pause, and then those application takes or uh, takes the first priority. So sequencing message is the process of numbering the segments so that the messages may be reassembled at the destination. So TCP is responsible for sequencing the individual segments. So in encapsulation is the process where the protocols add their information to the data in the other in the layered architecture. So when you look at this, we have what you call the BPDUs, the BPDUs. So on this, we expect application, and then the segment, it's transport. Um, then packets, there is internet, and then when it comes to this frame, it's network access, So it takes these two. So encapsulation is the process where the protocols add their information following the order of the layers. So at each stage of the process, a PPDU has has a different name to reflect its new function. So there is no universal naming convention for BPDU. In this course, the BPDU, the PDU's protocol data units are named according to the protocols of the TCP suite. So PDUs passing down the stack are as follows. So remember, this is the application. In encapsulation, it starts from application, and then transport, we have internet, and then these two, it's the network. That is encapsulation. That each layer it has to add, each layer's protocol it has to add its information in form of a header for easy for description, or for the easy direction, or for management, easy management. So at the application here, of course, there is the message, and it's going to be segmented. Once the segments are added with the transport layer, it becomes a segment. Then once a segment is added with the source destination network, it becomes a package. Once a packet is added with the source and then destination MAC address, it becomes a frame. And then once a frame is converted into zeros and ones, it becomes once the message is frame is converted to binary format, then of course there will be the bits. So the encapsulation example is it's top-down process. So it's from data, you go to segment, you go to package, and then from the package frame, and then lastly the bits. So here we are, since it's the encapsulation process. Now, as you can see, it's user datagram. The level above does its process and then add each down to the next level of the model. So this process is repeated by each layer until it is sent out as bit stream. So it's this with data. Now, when you look at this, that it's data, then segment, we have package, we have Ethernet. That is the, and then of course with the these are the PDUs. The PDUs, segment, packet, and then frame. Of course, after the frame, then the bits, the bits. So the encapsulation, this time it's top down. So data is de-encapsulated as it moves up. So it's not top down, but it's bottom up. This time the arrow, it will be pointing up. As you can see, it begins with, as you can see, it begins with the zeros and ones, the zeros and ones. So from zeros and ones, it's converted to a frame, then from a frame to a packet, from a packet segment, then to the original data. So when you look at this in position 1, we have received as bits, then converted to frame, converted to packet segment, and then data stream, and then it is presented presented by the application, the right application. Then we have data access. Data access. So with data access, we expect the addresses. So on network, we have two addresses. Those two addresses we have. Those two addresses we have. So the addresses are two, and we have what we call the MAC addresses, and then we have what we call the MAC address, and then IP addresses. The IP addresses. So here the network, when it comes to the network layer source, that both data link layer and network layer use addressing to deliver data from source to destination. So we have here the data link layer, those are the MAC address. And then we have network layer, those are the IP address. So network layer source and destination address, they're responsible for delivering IP package or delivering the packet from the original then to the final. Then we have what you call the data link layer. The data link layer, those are the MAC addresses, and these are the IP address. So the data link layer, both source and destination, are responsible for delivering data link frame from one network interface card then to another network interface card. What does that mean? That if I have a PC connected to the router, connected to a switch, then to the router, and then this is the PC. So for the MAC address, responsible for delivering data link frame from one network interface card, there is a network interface card here, and then there is another network interface card here. Then we have the IP address on this, IP address on this, and IP address here, then the IP address on this. Then we have network interface card here, network interface card there. Let me try to change the pen. Try to change the color pen here. Maybe green here will be the best. Okay. So for the IP address, if this is the source, assume that this is the source and this is the destination. So the IP addresses are not going to change. That's the reason why they are responsible for delivering the IP packet from original source to the final. So for them, they remain the same. But when it comes to data link layer source and destination address with data link layer, the frame it's going to be pushed or moved from this network interface to the next network interface, which is this. And then once this router receives the frame, now it's going to do the the encapsulation, because this PC it will do the encapsulation, and then the router it is going to do the de-encapsulation. And every time there is a de-encapsulation process, then the MAC addresses, the old MAC addresses within the frame, they are replaced. Now this time, before the router sends or forwards or routes the package, it will have to do the de-encapsulation by replacing the MAC address, which was this initially, and then the destination as this. This time, it's going to be this as the source, and then the destination MAC address, this. That is what it means, responsible for delivering the data link frame from one network interface card to another network interface card on the same network. So these are the fields of a frame. um, Not actually the flow of the flow of the message, that at the physical layer we expect synchronization bits, the zeros and one. At the data link layer we expect the destination and then source physical MAC address. Those are the MAC addresses. And then we have the network destination and then source logical network addresses. And then when it comes to transport layer, we expect destination and then source process number, which are the port numbers, the application numbers. And then the upper layer, in the upper layer here, that is what we expect the session layer. We expect presentation and then the application. So that one is responsible for encoding the application data. So I'm stopping here.